So in example 3H, we're first going to determine whether this curve represents a function or not. So back to drawing vertical lines. So I've got one here, and it intersects the curve in just one point. And I'll go ahead and draw another one. So maybe right here. And again, we are good. This vertical line intersects the curve in just one point. What's questionable about this particular graph is right here. You can see that this blue curve is getting closer and closer to the y-axis. It looks very close to the y-axis, okay, but it doesn't touch the y-axis. It gets closer and closer but never touches it. So if you drew a vertical line right here, because it is getting so close, you might think, okay, well, it's going to fail the vertical line test right here, but that is not what's going on. So let me erase this here. I'm going to draw a little arrow to right here. Okay, what's going on is that the curve is getting closer and closer to the y-axis, but never touches or crosses it. Okay, so this feature of the blue curve, it is called a vertical asymptote. Okay, so again, that just means in this case, a vertical line. The y-axis is a vertical line that this blue curve is getting closer and closer to. It never touches it or crosses it. Okay, so this curve does pass the vertical line test, because although the curve may look vertical right here, it is not. It gets infinitesimally closer to the y-axis but never touches or crosses it. Okay, so we are dealing with a function. All right, let's talk domain. So we know that we need to write down our x values. We need all the x values that this graph covers written in a compact manner. We know we need to work from left to right. Okay, so again, here comes the vertical asymptote. Can you identify the leftmost point on this graph? Okay, so again, the vertical asymptote is going down forever. Okay, if you see that arrowhead, it's going down forever. And this portion of the curve is getting closer and closer and closer, albeit infinitesimally closer to the y-axis, but never touches or crosses it. Okay, so you might think, oh, well, my leftmost x value is 0.001. Well, you can get even closer to the y-axis. Okay, so maybe your leftmost x value is 0.00001. But then you can get even closer, 0.000000001. Okay, so what we do in this situation, since we can't pinpoint the exact leftmost x value, we're going to go ahead and say it's 0. Okay, the leftmost point on this graph is like somewhere along the y-axis. The y-axis has an x-coordinate of 0. Okay, but since we never touch or cross the y-axis, x cannot actually be 0. So we exclude it with a parentheses. Okay, that's how you handle this situation. Okay, and then if you travel the curve and you want to follow the rightmost point, okay, remember the graph keeps going in this direction forever, so you can never reach a rightmost point. This graph travels in this direction. That is in the direction of positive x if you're looking along the x-axis. Okay, so in terms of x values, this blue curve exists from x equals 0, but not including 0 itself, and it travels off into the positive x direction. So that is your domain. All right, range. We need to write down the y values, and we need to work from the lowest to the highest point. Okay. All right, so again, when you're looking at both of these arrowheads, this portion of the graph, if you can see where my cursor is, it goes down forever. This portion of the graph goes out in this direction forever, but it's going not only right, but it's going down. So you can't really pinpoint the lowest point on this graph. The graph is traveling, though, in the direction of negative infinity along the y-axis, okay? We can identify, if you're really careful here, you can locate the highest point on the graph. It's right here, okay? And this point has coordinates 2, 2. Okay, that's the highest point on the graph. You're going to write down the y-coordinate, which is 2 here. And as far as including this point, okay, remember, there's no big fat open circle there. Okay, this is a solid portion of the curve, so it is considered to be included. Okay, so this means that this particular blue curve exists for y values 2 and smaller. Okay, all right, moving on to part I. Okay, we have a graph that consists of 2 separate pieces. Okay, so it's going to be a little different here if we're doing particularly domain. Okay, but let's first establish whether or not this is a function. This one's really simple. There are lots of places we can draw a vertical line and it will intersect our curve in more than one spot. Okay, so this is not a function. Okay, even though it's not a function, we can still talk domain and range. Okay, let's take a look at the domain. Okay, so again, with domain, you're just trying to figure out what x values this graph covers. All right, so again, we're writing down x values and we are going to be traveling from left to right in order to do this. Okay, so let's look at the first piece. Okay, this is the leftmost piece. Okay, remember with these arrowheads, the graph is going this way forever and it's going this way forever. So the graph is traveling to the left forever. Okay, so if you're way out here, say at negative 100,000 on the x-axis, you will certainly find an output either above or below. Okay, so this portion of the graph is covering it. Well, it's coming from negative infinity. Okay, put a parentheses, and this portion of the graph stops right here. Okay, it stops right here, it comes to a stop. Okay, that point, let me put it in a different color so it's easier to see. This point right here is negative 2, 2. Okay, so the graph stops there. So we're going to have to write down the x coordinate since this is domain. Okay, it stops at negative 2. Okay, so we're going to write from negative infinity to negative 2. Okay, there is no glaring open circle there. Okay, so you're going to include this point in the graph. Okay, all right, so put a bracket. And then there's no graph. Okay, I'm going to use my highlighter here. Okay, this piece leaves off at x equals negative 2, which is right here. Okay, and then we don't pick up again until x equals 3. Okay, so look at this little yellow region that I'm highlighting. No graph exists in between these x values. Okay, so let me erase this one little spot that I didn't mean to highlight. Okay, so the graph leaves off right here at negative 2, 2. It doesn't pick up again until right here, and that point is 3, negative 1. Okay, so you have this gap that I've highlighted in yellow over which you have no graph. Okay, so what's going to happen here is we've written down the domain for the leftmost piece, and then we're going to take a break. Okay, and we're going to have to union it with the domain of the other piece. Okay, so again, you're still traveling from left to right. Okay, so you eventually cross the yellow gap and you end up at 3, negative 1. Okay, that's the first place you pick up on the second piece. Okay, you're going to write down the x value because this is domain. Okay, the x value here is 3 for this point, 3, negative 1. Okay, and then after that, you ask yourself, what is the rightmost point? Well, because of the arrowheads, the graph is going to be traveling to the right forever. Okay, so the rightmost point, we'll just put positive infinity. Okay, at 3, negative 1, there is no open circle there. It is a closed circle. So you are going to want, well, there's no closed circle. There is a solid line. And so you're going to want to include the 3. Okay, so this is your domain. Okay, this graph, which consists of 2 separate pieces, it covers the x values negative 2 and smaller, as well as 3 and bigger. Okay, Range, okay, we need to write down the y values, and we need to go from the lowest point to the highest. Okay, well, if you pick either of the pieces, okay, let's start with this piece, okay, where's the lowest point? Well, the graph keeps going down, 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 down forever. Where's the highest point? It keeps going up, 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 up forever. Okay, same thing on the second piece. Okay, if this piece, it keeps going down, down, down forever, and then this way it keeps going up, 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 up forever. Okay, so the lowest point we can say is negative infinity. The highest point is positive infinity. These two portions of the graph, they both have a range of all real numbers. They span the entire y-axis. You do not need to write all real numbers union all real numbers. You don't need to do that, okay? Both pieces cover all real numbers. You can just write it one time, okay? So that's the range. All right, finally, last question. Sorry to give you so many. I just wanted to make sure you had a lot of different examples and lots of practice because this is really important, okay? All right, is this a function? Okay, this is a strange looking graph. It's a line segment and it's vertical, okay? So, you know, where do you draw your vertical line? Well, here's the deal, okay? It's gonna fail the vertical line test in one spot, on the vertical line itself, okay? So let me try that again with no eraser. Here we go. It's gonna fail the vertical line if you draw the vertical line on top of the vertical line itself, okay? So another way you can see this, if you just look at points on this graph and look at their coordinates, this is -5, 0, this is -5, 3, this is -5, 6, this point is -5, -2, okay? So what you can see here is that one input, the input, all of these points have the same x value, which is -5. That one input has several different outputs, okay? 6, 3, 0, -2, and there's lots more that I haven't written down, okay? So -5 is an input that has several different outputs, so this is not a function, okay? All right. Domain. Okay, if we're looking at the domain, we know we need to write down x values and we need to work from left to right. Okay, well, how do you really work from left to right here when your graph is a vertical line? It just goes up and down. Okay, well, again, I should not have erased these points that I put on here. Okay, I'll go back and put them. So we had -5, 0. I don't remember what else I picked. Maybe -5, 4. -5, 2, -5, -2, okay? It doesn't really matter what you pick, okay? Just look at various points on the line, okay? Again, they all have the same x coordinate. Any point on this line has an x coordinate or input of -5. It's the only input, okay? So the only x value that's on this graph is -5, okay? So remember how you write a single point. We saw that in another one of these graphs that we just looked at in this particular example. If you just have one input, you can list it using braces, okay? Or you can make it an interval from -5 to -5. Remember, you want to include it because, you know, -5 is the input if the output is -2. -5 is the input if the output is 0, and so on, okay? You want to include it, so you would put brackets. Okay, so either of these answers is acceptable. All right, lastly, let's look at the range. We're going to look at y values, and we're going to go from the lowest point to the highest. All right, so let me do some erasing here. The lowest point on the curve is this bottom closed circle, which is -5, -2. Okay, we are dealing with range here, so we're going to write down the y value. Okay, which is -2. This is a closed circle, so we're going to use a bracket to include the -2. Okay, then we're going to travel up to the high point, which is this open circle. Okay, it has coordinates -5, 7. Okay, so again, we want to write down the y value, which is 7 here. Negative 5, 7 is an open circle, so that means that point is not included in the graph. So as a result, we will not include 7 in the range, so we will have to put a parentheses. Okay.